Hello dear grade 6 children. Today you all are here with me to learn the second lesson of science, that is things around us. What are the things around us, children? Do you remember in the last lesson we learned about the environment? What is environment, children? Yes, I'm sure you know what environment is. Environment is our surroundings including us, right? So in this lesson also we are going to look at the environment in a different way. I hope you remember in the last lesson we learned about the environment or things in the environment. There are living things and there are non-living things, and we learn about the living things as plants, animals and microorganisms and their special features. You remember that, right, children? So in this lesson, things around us, we are going to look at the environment in a different way. So we will see what are the things we have to learn in this lesson. We have to learn about matter and energy. So these two are new terms for you all. I know that. We are going to learn what are coming under matter and what are coming under energy. And we are going to learn about states of matter. So when I explain this term matter to you all, you will understand that there are different forms of matter. These are known as states of matter. Understand? So we are going to learn what are the states of matter, what are the special characteristics of these states of matter. And then we are going to learn specific properties of solid matter. So when I explain this, you will understand that solid is one state of matter. Understand? We are going to specifically learn about the special features of solids. So we will start the work. Look at this, children. What is this? Now you all are familiar with this type of environment. Now this is a classroom environment. Right, children? Do you remember in the previous lesson also we learned about classroom environment? You remember that, right? So what is this? It's a very beautiful classroom. What you all can see here, children? Shall we write down the things present in this classroom? So first take a look at this classroom, children. What are the things you all can see? Yes, I'm sure now you can even start writing the things in this classroom, right, children? So I can see many desks here and chairs present, and I can see the books and pencils and pencil cases also there. What are the other things? So what is this? This is a speaker. In some classrooms, we can see to give special messages, to deliver messages, there are speakers, right? We can see a whiteboard and a flower vase. Teacher's table is there. What else can you see here? There are 3 big windows. So because of the presence of these windows, you all can see this classroom environment is a well-lit environment. Light comes through these windows. So light is there. So what if someone delivers a message using this speaker? You will hear sound as well, right? What else? Let's say that you all are sitting right next to this window. What would you feel? When the environment is very sunny, you will feel the heat. Understand, children? So shall we write down what is present in this environment, children? You all can start with me. We will write down what are the things in this classroom environment. I am going to start with desk and chairs. Those things I can see easily. Desk, chairs, and I will write, I can see a fan over here. I'll write a fan. And whiteboard. Number 5. Pencils. 6. And I'm going to write light because I mentioned that. Light and speaker. Because of the speaker, sound comes out. Therefore, I'm going to write sound. Okay. And heat. I mentioned that as well. What else? What are the other things we can see? I can see the teacher's table and the flower vase. I will take the vase. 10. What else is present here, children? There are so many other things you can write, but I am going to write something else now. Even though there are so many things you can see, I am going to write another thing you can't see here. That is air. What is air? Now air surrounds us, right? So we are surrounded by air. So what happens here? Even though you can't see air, this classroom is filled with air. Even our surrounding, entire surrounding filled with air. So because of the gases present in this air, we can inhale oxygen, and when plants do photosynthesis, they can take carbon dioxide in. You remember these points, right? So here, even though we can't see, I'm going to write air as well. Right, children? Look at this list. I'm sure you must have written different other things as well. Now here I have desk, chairs, fan, whiteboard, pencils, light, sound, heat, vase and air. So it's very clear some of these things you can see very clearly, and some of these things you can't see clearly. Can you see the sound? You cannot. Can you see air? We can't. Right? So when you look at these things, we will see what are the special properties of these things, children. Now we will take desk. If you try to lift the desk, what will you feel? You will feel it is heavy, right? What about the chair? Chairs also of different sizes. There are small chairs. When you were in your lower grades, like grade 1 to 5, you used to sit in those small chairs, right? Now what about now? You have big chairs now. So when you consider small chairs, they are easy to lift. But what about the big chairs? It's a little difficult than those small chairs, right, children? So what about the whiteboard? Whiteboard, there are big whiteboards and small whiteboards as well. So big ones, very difficult to lift. You normally don't lift them, but if you try to lift it, it is difficult. That is because it is heavy, right? So what about pencils? Pencils are very light. It's not that heavy. But what will happen if you keep on filling the pencils to this type of pencil case? Let's say if you have 2-3 pencils, it won't be that heavy. But if you have 50 pencils in the same pencil case, it will be heavier, right? So it means there's a mass or there's a weight to these pencils. Now remember, I mentioned this mass and weight, 2 words. What is the meaning of mass? What is the meaning of weight? In day-to-day life, we say when something is heavy, it is up because of its weight. But remember, in science, we are going to learn the most correct word for this is mass. That is why I am going to mention that one. So I was explaining about this pencil case with many pencils, about 50 to 100 pencils. It will be heavier because the mass increases. What about light, children? Is light heavy? Does it have a mass? Can you measure the mass? Like 100 grams of light, 500 grams of light, 1 kilogram of light? Can you measure like that? We can't measure the mass of light. But if you measure the mass of all these things like desks, chairs, pencils, we can measure the mass in grams or kilograms, right? But light, you can't measure the mass. What about sound and also heat? Can you measure the mass, children? What about these two things? We can't measure the mass of these type of things as well. Sound, heat, we can't measure the mass. Understand? Now we'll consider about a different characteristic, children. Now look at these objects present in this classroom, children. Now if you look at this desk and chairs, you all know that they need a particular place to keep them, right? Take this pencil. Now let's say in the pencil case, you need some space for this pencil. You will not understand this if I consider about only one pencil. But what will happen if I keep on filling, keep on inserting pencil to the same pencil case? At one point, what will happen, children? That pencil case will run out of space and you can't even close the pencil case because it is full of pencils. So it's very clear for the pencil, it needs some space. Understand? What about the desk and chairs, children? They are also the same, children. Let's say that there are about 10-15 desks over here. What if I try to put more and more desks and chairs into this classroom? We will be able to put many other desks as well, but at some point we won't be able to put more and more desks, because when this entire room is filled with desks and chairs, we can't put more and more desks and chairs into this place, this classroom. What is the reason, children? That is because these desks and chairs, they occupy a certain space in the environment. Understand? Now I would like to move into this light. What about light? Does light need any space, children? Now you can see this light comes through this window, right? What if I light a light bulb, or maybe 10 light bulbs over here? Whatever the amount of light comes to in this classroom will never run out of space. Understand? So it's very clear there are some things which occupy, which need space in the environment. And there are some other things in the environment, they don't need space in the environment. And look at heat. Heat needs space. There's no space that they need, right? So light, sound, heat, they don't need space, children. Understand? So it's very clear, when we take some objects in the environment, they have a mass and at the same time they occupy a space in the environment. Understand? And some other things are there, they don't have a mass and at the same time they don't occupy any space in the environment. Understand? So we are going to put these things into a table now. Look at this. We have the 10 items we wrote down using that classroom, things around us. And here we have one column we are going to mention, that is having a mass. Here occupying space. Now we understand there are some things in the environment, they have a mass and they occupy space as well. And there are some other things in the environment, they don't have a mass and at the same time they don't occupy space in the environment. So we all are going to fill this table. You all can start with me. What about the desk? They have a mass. I'm going to put a tick over here. What about space? They need a space. That is why I told you, if you keep on filling this desk into the same room, at one point this room will run out of space. Understand? Therefore, they occupy space. What about chairs? It's a thing that you can feel very well. Therefore, it has a mass. Remember, I told you there are small chairs with less mass. And space. They need a space. What about the fan? Fans also need space and there's a certain weight or mass to this one. Therefore, having a mass, correct, occupying space is also tick. Whiteboard, I explained you, there is a mass and they need a certain space on the wall. Pencils, obviously I explained you how it happens. Mass is there, space is there. Light, can we measure the mass of light like 100 grams, 200 grams? We'll never be able to do that. So here, no. What about space? Doesn't need space. And I explain you, when you consider heat and sound, there's no mass and no space as well. Doesn't occupy space. vase, flower vase. Let's say that we have a flower vase. If one vase is there on the table, it will take a small space and it has a certain mass to this vase, right? If we keep 10 vases on the table, it will take more space. Therefore, mass present occupies space also present. So when it comes to this air, did you already fill these two columns, children? I am sure some of you have marked this as no mass and don't occupy space. But for now, I am going to write for air. Air has a mass and air occupies space. I will explain why. Now you all think that because we can't see air, because we can't feel air, air doesn't have a mass. And at the same time, air doesn't need any space. But now I'm going to experimentally prove that air has a mass and air occupies space in the environment. So we'll do the experiments now. Right, children? We have the experiment to do here. Find out whether air occupies space. Now you remember I told you that I am going to prove you that air has a mass and air occupies space. We are going to do that. So we have the experiment here. Do you remember in which way we recorded an experiment, children? Do you remember all the steps? I hope so. So what is the first step, children? You have to write down the title of the experiment. So it comes under experiment. Step 1, experiment. So here what is the experiment today? Find out whether air occupies space. We are going to prove that air occupies space. We are going to prove it experimentally, right? What is the second step, children? The things you need should be written under materials. So what are the things you need, children? Remember, now this experiment is a very easy one. You all can do this at home very easily. Understand? So we need only 3 things to do this experiment. We need a water basin. Okay, but in the lab we are going to use, instead of a water basin, we'll be using an instrument, a transparent water vessel, right? That is known as trough. Here we need a water basin and a dry handkerchief or maybe some dry tissues as well. And we need a dry glass. We will write down water basin, dry handkerchief, and dry glass. Right. So the first step, experiment, find out whether air occupies space. And step 2, materials, the things you need to do this experiment. We need a water basin. You can fill the basin with water. Understand? And we need a dry handkerchief or dry tissues and a dry glass. So we will go to the next step of the experiment. What is the next step, children? Yes, the next step is method. So under the method, you have to write down what are the things you do in this experiment. Here, what do we have? A diagram. Remember, children, sometimes if you have to write many steps, it's very easy to represent it by drawing a diagram. Look at this diagram. By looking at this diagram, it is very clear what we have to do here. Understand? So what do we have to do here, children? We have to take the dry glass and we have to place the handkerchief in the bottom of this dry glass and we have to press it tightly so that it won't fall when you immerse it. So look here, the next diagram. You have to immerse this glass with handkerchief. You have to immerse it upside down and vertically. You should not tilt it. You have to make sure that you immerse this dry glass upside down vertically. Understand? You should not tilt it. So here you can see all these diagram, all the parts are labeled. Okay, so make sure it's very easy to represent what you have to do by using a diagram. Understand? So whenever you draw a diagram, you have to label all the parts in that diagram. So you can see in this one, we have labeled the dry glass. Here the handkerchief is labeled, and here also handkerchief and water basin. Understand? So this is very easy. Only one step we have to write here. I'm going to write, we have to set the apparatus. So we have to make the setup like this, and we have to immerse the glass vertically upside down. Understand? We will write that. Set the apparatus. Apparatus means setup. As shown in the diagram, and immerse the glass upside down vertically. You should not tilt this. Vertically in the water basin. Vertically in the water basin. Right? Set the apparatus as shown in the diagram and immerse the glass upside down vertically in the water basin. Okay, this vertically is very important. You should not tilt it. You should immerse it vertically. Understand? So we are going to check whether air occupies space. So what do we need to do this experiment? We need a water basin, right? And here I am going to use a beaker. When you do it at home, you can even use a dry glass. Now this is a dry beaker. And I am going to use some dry tissues here. So what do I have to do first? I am going to put this inside and very tightly. Place this tissue very tightly. Okay, so when I do this, it will not fall. Okay, so now what I have to do is, we are going to do here, I am going to immerse this beaker in this water vertically. You should not do this, you should not tilt this, you have to do it vertically. Right. I placed it on this water basin. Right, I am going to take it out now. Okay, and I am going to wipe this very well. Right. Okay, and I am going to take out this tissue, and I can see clearly it's not wet. Now what we think is, when we immerse this beaker in this water, we always think that water will go inside and this will get wet, but it's not. It's very dry, and I can feel even inside the water beaker this beaker is very dry. So why does this happen when we immerse this? Now you know that, you can see that when I place this very tightly, only this part contains the tissue, other part looks empty. So in that case, when we immerse this like this, why doesn't water go inside? Children, even we can't see, even though this bottom part contains this tissue, this part is filled with air, right? So the reason when we immerse this, the reason that water doesn't go inside is the air occupies this entire other space. than the space that occupied by the tissue. The other space is occupied by air, right? So water, even the water tries to go inside, that air won't let it go inside because air has occupied this space. Okay, children? So this is the best way we can identify that, we can prove that air occupies space. I'm going to do the same experiment again in a little different way. We'll see. Here this time I am not going to immerse it vertically. I am going to tilt it a little bit and I am going to immerse it. So when I tilt, you can see air bubbles which is trapped inside, they are coming out. So it means air trapped inside this beaker, it comes out, right? So what do you think? If air trapped inside comes out, there will be space for the water to go inside. We will see. Right. I am going to take it now. I am going to wipe it again. I am going to wipe it very well outside. So here I am taking out the tissue. You can clearly see it's soaked in water, right? So it's very clear that when you tilt this, water goes inside. The reason is air trapped here comes out, right? Therefore water has enough space to go inside. But you immerse it vertically, there's no space for water to go inside because the entire space is occupied by air. Did you watch the experiment? Did you do the experiment at home? I hope so. Right. So what were the observations, children? What happened when we immerse the glass vertically upside down in the water basin? What did you see? It was very clear that water didn't enter the glass. What is the reason? You saw that when you tried to immerse it vertically, water did not go inside the glass. Right? And at the same time, when you took out the handkerchief, that tissue, what did you observe? It was still dry, right? So what do we write under observations? What we saw during the experiment. So I am going to write step 1, water does not enter the glass. That's something we observed, right? Water does not enter the glass, therefore inside the glass it was still dry. And what was the second observation? That handkerchief was dry. Handkerchief did not get wet. Did not get wet. Okay, water does not enter the glass. Handkerchief did not get wet. These were the observations. Understand? Now we are going to write down the next step of the experiment, the last step, that is conclusion. So what can we conclude? What is the decision that we can come up with after doing this experiment, children? We are going to write under conclusion, right? So what is the conclusion of this experiment, children? I even explained it during the experiment. Why can't water go inside the glass? That is because even though we can't see, glass is filled with air, right? So if I draw the glass like this, you know, the bottom of the glass has the handkerchief or the tissue. Now here we have the handkerchief. I will mark it with a different color. Right? Here we have the handkerchief. Here I used a tissue. You can use a handkerchief. Right? Okay. So this part is filled with the handkerchief. Handkerchief occupies this space. What about this space, children? Can you see there's anything? we can't see anything, right? But even though we can't see, there is air here. This entire space is occupied by air. So that is why when we immerse this glass vertically in water, this air won't let water go inside because this space is already occupied by air. Understand? So we can come to a conclusion that air occupies space. Understand? Isn't it very easy, children? So we will write down the conclusion. It's very easy if you draw a diagram for this one and if you show it like that, it's easy to understand. Okay? So we are going to write down the conclusion. Right. So I'm going to write water cannot enter the glass due to the presence of air. Therefore, air occupies space. Therefore, air occupies space. So remember, this last sentence is the conclusion. We wrote all these other steps here so that easy to understand. Okay, children? So you can simply draw a diagram like this, and we can, here I wrote, water cannot enter the glass due to the presence of air. Therefore, air occupies space. That is the final conclusion that we can come up with after doing this experiment. Understand, children? Right. Right, children. You remember I told you that I am going to experimentally prove you all that air occupies space and air has a mass. Now I already proved that air occupies space. Now I'm going to show you that air has a mass as well. So our experiment is to find out whether air has a mass. So that is the experiment or the title, right? So next we are going to write down the materials, right? What are the materials we need here? Now only a few materials we need here, children. So even this experiment you all can do at home. Okay. So we need two balloons. We need two balloons. And we need a meter ruler. If you can't find a meter ruler, you can even take an even stick. Meter ruler. And we need several pieces of thread. Okay? Pieces of thread. Pieces of thread. We need two balloons, we need a meter ruler, and we need several pieces of thread. Understand? So we will see what we are going to do. Right, children? So this is the method. What do we have to write under the method? We have to write what we are going to do in the experiment. And at the same time, I explained you, sometimes instead of writing all the steps, we can draw a label diagram. So when we look at the diagram, it's very easy to understand what we have to do here. So what you all have to do here, it's very clear. You have to fill the balloons with air and remember these balloons should be equal in size. Okay. And you have to hang these two balloons with pieces of thread on either side of the meter ruler. And you have to hang the meter ruler from its middle. Okay. And finally, you have to balance this meter ruler until it lies horizontally. You all can see it's like a scale here. right? So it is equal. So that is why I told you it's better if you all can fill air into these balloons, and the balloon should be equal in size. So it's very easy to balance the ruler. Remember, for all these steps, you all can draw a diagram, and you should not forget to label the diagram. Look, meter ruler, thread and balloons with air, they all are labeled. Okay, so then what we have to do? So after we set the apparatus like this, we have to make a hole only in one balloon, and we have to observe what happens. So we will write down. Under method, we have to draw the diagram, and we are going to write set the apparatus as shown in the diagram, and make a hole in one balloon. Make a hole in one balloon. Set the apparatus like in this diagram, and you have to make a hole in one balloon. Understand? So we will do the experiment now. Okay children, now we are going to do the second experiment of the second lesson. We are going to check whether air has a mass. Most of the time we think air is not heavy, it doesn't have a mass because we can't feel it. Let's see. Now here I have two balloons fixed to this meter ruler, right? Both the balloons filled with air, right? It's fixed to this laboratory stand. So you can see this is like a scale. This is like a scale in some stores that you can see. It's a balanced one, right? So it means you can see, because this ruler is balanced, we can say that the mass of these two balloons are equal, right? So now what I am going to do is, here I have a pen. I am going to burst one balloon. I will choose this one. So observe carefully what happens. Now you all can see this one side is the balloon, that filled side is heavier than this side, right? Now you might think because now one piece is over here, this is heavier. I am going to place that as well. Still this side is the heaviest side, okay? So why? What is the reason children? This side now you can assume that even though air is not there, the entire balloon is, all the pieces are here, right? This side also we have the entire balloon, but this side is heavier than this side, right? So what is the reason? In addition to this balloon, this side we have air filled with the balloon, okay? So if air doesn't have any mass, even after bursting the balloon, both the sides should be equal, right? But here this side clearly goes down when we burst this, when we send air from this balloon. The reason is air has a mass. So in this way, we can come into a conclusion that air has a mass. So you saw what happened when we were doing the experiment. What were the observations, children? It was very clear. When you make the hole in one balloon, that side goes up and the other side with air goes down. So you can show it using a diagram like this. This is the meter ruler, and the side with the balloon with air goes down, and this side goes up. Now this still has the balloon, but no air here. Right children? So this was the observation. The meter ruler loses its balance and one side goes down. Right? We will write that. Meter ruler loses its balance and the side with the balloon with the balloon with air. Side with the balloon with air goes down. The meter ruler loses its balance and the side with the balloon with air goes down. It means this side is heavier than this side, isn't it, children? So what is the conclusion? What is the decision that you all can come up with after doing this experiment, children? This happens because air has a mass. Just imagine if air doesn't have a mass, what will happen? It won't make any change. With or without sending air out, it should be still balanced. Look at this one. Now 2 balloons with air here and the meter ruler is balanced. Okay, but here what happens? Only one balloon has air and the other one doesn't have, and this side goes down. Why does this happen, children? Now both the sides have the balloon. So if air doesn't have a mass, because 2 balloons are here, that should still be balanced. But it doesn't happen. It means this side becomes heavier because of the presence of air, right? In addition to the balloon, this side has air as well. This side only the balloon, this side balloon plus air. Understand? So this side has balloon plus air and this side goes down. This side becomes heavier. That is because air has a mass. Understand? So by doing this experiment, it is very clear that air has a mass. We will write that down. Conclusion. Air has a mass. Right, children? So I hope it's very clear. You all can do this experiment at home. Right? Right, children? So we discussed about mass and weight, all these things. Even earlier I mentioned you, even in day-to-day life we use this term weight. But actually when we learn science, we learn this term as mass. What is this mass? How do you define mass, children? The amount of matter. The amount of matter. For now you can take this matter as substances, right? The amount of matter in an object is referred to as the mass of the object. Okay, children? Let's take a piece of iron. Right? If you take a piece of iron, it is made out of iron particles. The substances present in it is iron particles. So what happens if the amount of iron particles present in a certain piece is very high? That it decides what the mass is. Okay, so the amount of matter in an object is referred to as the mass of the object. So now piece of iron is heavier. If you take the same size piece of, let's say, cotton wool, what happens? It's very light. What is the reason? The amount of matter present in iron is higher than that of the amount of matter present in cotton wool. Understand? That is why if you take the same size pieces of cotton and piece of iron, what will happen? This piece of iron will be heavier. That is because here the mass is higher than that of the cotton wool. Understand? So the amount of matter in an object is referred to as the mass of the object. Understand? So what are the units you can use to measure mass? Sometimes small masses like some medicine you can measure in milligrams, right? And you can use kilograms, grams as well. There are different units you can use to measure mass. Those are kilograms, grams, milligrams. Okay, children? So when you take all these units, children, kilogram is used as the SI unit or standard international unit, right? We have many units that we can measure mass, but remember only one unit is internationally accepted, right? So here the international unit of measuring the mass is kilograms. That is a fact that you have to memorize. We have other units as well. Out of all these units, the international unit, or that is also known as SI unit. SI unit means, children, Standard International Unit. Standard International Unit. That is why Standard International, SI unit. Okay. So when we take a certain quantity, to measure that particular quantity, we have different units. Only one unit is considered as the SI unit. Okay. So when it comes to mass, there are many units you can use to measure mass, like grams, kilograms, milligrams, but only one SI unit is there. So when it comes to mass, what is the SI unit, children? That is kilograms. You have to memorize this one. This is a fact. Understand? Right. Matter and energy. Now this is a new topic. These are new terms. We are going to learn what are matter and energy. Even though you don't know what matter and energy means, you have already learned about this matter and energy. Look at this. Things with a mass and occupy space. Right? Things without a mass and do not occupy space. Didn't we learn about these type of things, children? Now think about that classroom. Do you remember when we list out those things in that classroom? We discussed that there are some things, they have a mass and at the same time they occupy space. What are those things, children? Do you remember what we wrote there? Shall we write down here? I remember we were writing desks. And we wrote pencils. And I remember I explained you air as a thing with a mass and occupy space. Now we proved it experimentally. So you all know that air also has a mass and air also occupies space. We'll write that as well. Air. And many other things as well. Right? So we know that there are things with a mass and occupy space. And the second thing, things without a mass and do not occupy space. We'll go back to the classroom. Do you remember what we learned under this classroom, children? We learned about there are some other things. They did not have a mass and they also don't occupy a space. What are the things we discussed about? I'm sure you remember. We discussed about sound, and when we discussed about light, what else we discussed about? Sound, light, heat, right. So there are other things also coming under things without a mass and do not occupy space. Understand? So remember, children, we can give a special name to these things with a mass and occupy space. There's a special name, that is matter, right? Things with a mass and occupy space are known as matter. And things without a mass and do not occupy space are known as non-matter or energy, right? They are known as energy. Even non-matter is also correct. Non-matter. Understand, children? So it's very clear when you look at the environment, there are some things, they have a mass and at the same time they occupy space. Examples like these. And those type of things are known as matter. Now this is the scientific term. Now you all know what matter is, right? So there are some other things in the environment. They don't have a mass and they do not occupy space. And they are known as energy or non-matter. Examples, sound, light, heat. What are the other examples, children? Electricity. Electrical energy is also coming under this one. So I will write that as well. Electricity. Right? Other energy is also there. Understand, children? So I hope it's very clear there are two things in the environment. Some of them have a mass and they occupy space, and they are known as matter. And other things are there, they don't have a mass and they do not occupy a space, and they are known as energy. So we are going to see more examples regarding these two things, okay? Right, children. So these are some examples for matter. So things with a mass and occupy space are known as matter. So in day-to-day life we call things, this is actually matter. So scientifically you all know that what we call things like this, right? They are coming under matter. Now you don't have to explain. Now there are some things with a mass and some things they occupy space. You don't have to say like that anymore, because now you know we can call those type of things as matter, right? So we normally refer to things in daily life as matter. Look at these examples. Some things we use in our day-to-day life, right? Milk, and here's a cola bottle, a bell, balloons, a fruit, some books, and a hot air balloon, and a pen. There are so many other things, children. Look at your environment. Whatever the environment you live in, you can find so many things like this, right? Things with a mass and occupy space. So I'm sure you will write down a list of the things around your environment, okay? So the next one, things without a mass and do not occupy space are known as energy or non-matter. So what are the energies that we learn, children? We learn about sound. We can write it as sound energy, right? Sound energy. What else? Light energy. Heat energy. And I explain you electrical energy. Right? There are some other different types of energy as well. There's this other type of energy called kinetic energy. Now, kinetic energy is the type of energy stored in moving objects, right? Any moving object has kinetic energy in them, right? Kinetic energy. Right, children? There are different types of energy. In day-to-day life, we use these type of energy to do our day-to-day activities. We are going to learn about the use of these different types of energy in the other lessons. Right, children? Okay. So here we are going to write down again things around us. There are two different things around us, matter and energy. Now remember, children, in the first lesson also we divided things in the environment or things around us. There we use this factor whether they grow or not. And according to the growth of the things, we divided those things as living things and non-living things. Here the factor we are going to use in order to divide the things around us as matter and energy, the presence of mass and occupying space. That factor we are going to consider. So you all know that we can divide the things around us into matter and energy. I told you energy is again known as non-matter. Right, children? So what are the differences between matter and energy? We will write here matter have a mass and what is the other one? Occupy space in the environment. Occupy space. Understand, children? What about non-matter or what about energy? Don't have a mass. They don't have a mass. And don't occupy a space. Don't occupy space. Right? So it's very clear the things in the environment or the things around us, there are two things, matter and non-matter. Matter means the things with a mass and the things that occupy space in the environment. Understand? And non-matter or energy means the things that do not occupy space in the environment and the things that do not have a mass. Now you can even write down the examples. What are the examples? We will write. Okay. What are the matter? Pens, pencils, book, right? Those are coming under matter. Non-matter or energy. What are the energy? Sound energy, heat energy, light energy. Right? They are coming under non-matter. Understand, children? I hope so. Right. Okay, children. Now we learned about matter and energy. We learned that matter has a mass and they occupy space in the environment, and non-matter, they don't have a mass and they don't occupy space in the environment. And in this lesson, we are going to further learn about matter. Right? So now we are going to learn about states of matter. Okay, children? So do you remember in the beginning of the lesson I told you this matter has different forms and they are known as states of matter. Remember, children, there are 3 states of matter, that is solid state, liquid state and gaseous state. Right? Or very simply, solids, liquids and gases are coming under states of matter. So what are we going to learn here? What are the states of matter? There are 3 states of matter: solid state, liquid state and gaseous state. Okay. So what are the examples? Matter in solid state. There are so many solid things. What are these solid things? You can touch them very easily. You can feel. They are very hard. Okay. Some of them are less hard as well. You can feel them very well. They are coming under solids. What are the solids? Now this pen is a type of solid, right? Examples: pen, a piece of iron. Iron is coming under solid, right? What else? Firewood. Day-to-day life, some people, they use firewood, right? Firewood is coming under solids. Firewood and so many other things coming under solids. Understand? What about the matter in liquid state? Now we learn about solid state and then liquid state. What are the liquids that we use in our day-to-day life, children? We use water, the main liquid, and milk, right? Coconut oil, kerosene oil, different types of other oils as well, right? Coconut oil, kerosene oil, and other examples as well. And mercury, which we use to fill the thermometer bulb, that is also a liquid. That is a metal, but that is coming under a liquid. Okay? Okay. The third one, matter in gaseous state. We learn about solid state now, liquid state and gaseous state. What are the matter that present as gases? Now you are familiar with 2 gases. In the first lesson we learned about oxygen and carbon dioxide. So they are matter coming under gaseous state. Okay? So oxygen, carbon dioxide, right? So in day-to-day life you use LP gas in gas cylinders. Okay? LP gas. LP gas means liquid petroleum gas. LP gas. What else? Water vapor, that is also coming under gaseous state. There are so many gases. and others. Understand, children? So what did we learn so far, children? There are things in the environment. There are two different types of things. What are the two types of things? Matter and non-matter. Matter means the things with a mass and occupy space, and non-matter or energy means the things without a mass and do not occupy space. And we further learned there are three states or three forms of matter. What are these three states, children? Solid state, liquid state and gaseous state. Did you understand this, children? I hope you understood this one. Okay. We have an assignment to do. Categorize the following into solid, liquid and gas according to the physical states. Understand? Now we have a list of things here. We have to categorize them, group them into solids, liquids and gases according to their physical nature, physical state. So we learned that matter has three states. Okay, or there are three states of matter. So those three states are solids, liquids and gases. Here we have a list. We have to put these things in the list according to the nature, physical nature. We have to categorize them as solids, liquids and gases. Now you all can start to do along with me. Okay? We will take the first one. Jaggery. Jaggery, you can feel it's hard, right? There's a certain shape, therefore it goes under solids. So I will write jaggery here. Jaggery. Because we wrote it, I'm going to strike it off. Water. Water is a liquid, right, children? Water goes to this column. What about sugar? Sugar also, it's hard. We can feel it, right? Therefore, sugar is also coming under solid thing. Sugar. Brick. Brick is definitely a solid. Okay. What about the pen? Pen is also a solid. You can feel it's hard, right? It's a solid. Coconut oil, I told you, it is coming under liquids. Kerosene oil, coconut oil, soya oil, those things are coming under liquids. And then air. Air is coming under gases. It's a mixture of gas, right? Air is a mixture of different gases. Therefore, it goes under gases. Air. Table, you can feel it's hard, right? Table is going under solids. Water vapor. Water vapor can be found in atmosphere, in air. It's a type of gas, right? So water vapor goes here. Cotton wool. Now cotton wool is a very soft thing, very light thing. But still it's coming under solids. Right, children? Cotton wool. Right. Rice, we can touch and feel rice grains very clearly, right? Rice coming under solids. Right, rice here. Milk. Milk is a liquid. And oxygen. Oxygen I gave you under gases. It was an example under gases, right? So oxygen goes to gases. And king coconut water, it's a liquid. King coconut water. Coal. What is coal? Right? Coal is a type of fuel. It is coming under solids. Diamond. Now diamond is something very hard. You use diamond to make jewelry and to make special machines to cut glass, right? It's a hard thing. So diamond is going under solids. And gems. Gems is also going under solids. Gold. Gold is a solid. We can feel, touch and feel this gold jewelry, right? So, gold also goes here. And sand. Sand is something rough. You can touch and feel. Sand also goes here. So, it was very clear, children, right? I hope you also did this with me. So you can look at your environment and you can categorize the things in the environment as solids, liquids and gases. Understand? So it's very clear that matter belongs to one of the three states of solids, liquids and gases. We learn about three states of matter as solids, liquids and gases. Understand? So matter can be classified as solids, liquids and gases according to their physical state or physical nature, how they present in the environment. Some of the substances, some of the matter present as solids in the environment, some present as liquids in the environment and some present as gases in the environment. Okay, so matter can be classified as solids, liquids and gases according to the physical state. Understand, children? So now we are going to learn about solids, liquids and gases further about their special characteristics. Likewise, characteristics of solids. Look at these three solids given here, children. Brick, bat and stone. What are the special characteristics, children? Look at the shape of this brick. It's a cuboid, right? Look at the bat. It also has a special shape here. Okay, now stone. Stone doesn't have a special shape. It's irregular. And when you think about the shape, do these solids change their shape time to time, children? Look at the brick. Now if you have this brick today and tomorrow when you go out, will this change its shape into something else? No, it won't. Bat and stones are also the same. But remember, with an external force, we can break the brick. That is a different thing. But brick doesn't change its shape. Or bat and stones as well. Understand? That is because they have a definite shape. Understand? That is why we can feel it's hard. We can touch their corners and feel it because they have a specific shape. Right? So brick, bat and stone, they have a definite shape. So every solid, they have a definite shape and this is a special characteristic of solids. Understand, children? What can you tell about the space occupied by these matter, children? Space occupied by these objects, children. What can you tell about that? What is the meaning of this space occupied by these objects in the environment? There's a special term that we can give to the space occupied in the environment that is known as volume. Right? Now volume means, now this is a new term. Volume means the space occupied by a certain object. Right? The space occupied by a certain object is known as the volume of that object. Understand? So look at these different types of solids. What can you tell about the volume of these objects, children? Now, they don't change the shape time to time. At the same time, what can you tell about the size? Right? Size also won't change. Based on the size, it needs a certain space in the environment. Okay? So they don't change the shape and at the same time, they don't change the size as well. Therefore, what happens? The space occupied by these objects also They don't change. So when we take these solids, we can see there are two special characteristics. They have a definite shape. Definite shape. Understand, children? So definite shape is the first characteristic. What can we tell about the volume? Now what is volume? Volume means the space occupied by a certain object. Understand? So what can you tell about the volume? Volume is also a definite one. Therefore, they have a definite volume. So definite shape is the first characteristic of solids. Second characteristic is definite volume. Understand, children? So characteristics of solids. Solids have a definite shape. Solids have a definite volume. Understand? Okay. So a solid has a definite shape. A solid has a definite volume. So when we discuss about the shape and the volume, these are the special characteristics of a solid. Did you understand, children? Right. Now we are going to look into liquids. Okay. Right, children. Before we learn about the characteristics of liquids, we are going to learn how to measure a certain volume of liquid correctly. Right? Measuring a liquid using the measuring cylinder. So here we are going to learn how are we going to measure a certain amount of liquid using this instrument called the measuring cylinder. I am going to show this in the lab. Understand? So the measuring cylinder is used to measure liquids in the laboratory. This is a special glassware that we can use to measure a certain amount of liquid. Understand, children? So, how do we measure a certain amount of liquid using a measuring cylinder, children? I will teach you. Now, when we take the measuring cylinder, it's made of glass. You can clearly see through it and it is calibrated from bottom to top. Understand? So, 0 is at the bottom. Understand, children? So, if we take the measuring cylinder, I will draw it like this. Something like this. Okay. Right? And I will mark here 0, 5, and this is, we'll say, milliliters. And 10, 15, 20, 25, likewise. Understand? So when you measure the liquid, there's a certain way that you have to do that. Okay, children? I will take a different color. Let's say that we have the liquid like this. I'm going to draw the liquid like this. Look at the shape of these, children. Here, this is the liquid that we are going to measure. Okay, children. Now, normally you all know when we draw a liquid in a glass or a beaker, you will draw it like this. The surface is flat. But remember, children, if you observe clearly, the upper surface is curved. This curved surface is known as the meniscus. What is the term? Meniscus. So when you consider a liquid, the upper surface is curved and this is known as the meniscus. So how do you measure the amount of liquid using a measuring cylinder, children? Listen very carefully. You have to keep your eye as it is leveled with the lower curved part of the meniscus. You can see there are two parts of this meniscus. I will take a different color for this one. right? So look at this part and look at this part. This is the upper part, this is the lower part. Understand, children? Remember, you have to keep your eye level with the lower curved part of the meniscus. Right, children? The eye should be level with the lower curved part of the meniscus. So according to this one, this is about 20 milliliters, or maybe between 20 to 25, you can say 21 milliliters. Understand? So if you keep your eye level over here, right? If you take the measuring cylinder like this and observe, or if you just take it like this and observe, it is wrong. First of all, you have to place this measuring cylinder on a flat surface, on a table. Understand? You have to place the measuring cylinder on a flat surface, and then you have to go down as your eyes align with the lower curved part of the meniscus. Understand? So then only you have to take the reading. So now we are going to watch that experiment. We are going to learn what is the correct method of measuring a liquid in the lab. I already explained you that there's a certain special method that you have to use in order to measure a certain amount of liquid in the lab. Do you remember that? I hope so. So when you fill that liquid, certain particular liquid into a vessel, you all can see, if you observe clearly, you all can see the surface of the liquid is not flat, it is curved. Right, this curve is known as the meniscus, right? So when you measure the liquid, when you read the volume of the liquid, you have to take the reading of the lowest curved part. Okay, I explained it earlier. So if you look at this one, you all can see now this is a burette, right? This is a burette. You all can see it's very nicely curved, this part, right? So when you measure this amount of liquid present here, I have to take my eye level along with line with this meniscus. If I observe it like this, it's not correct. I have to take my eyes in level with this meniscus to the lowest curved part. So I am going to take it. You all can see the here what is the measurement. I also can see from this side, that is 13 milliliters. So what is this, children? This is the measuring cylinder, right? This measuring cylinder is also used to measure the amounts of liquid in the laboratory, right? Let's say that now I have a certain amount of liquid here. If I try to take the reading like this, is it correct? You all know it's not correct. Let's say that if I take it to my hand, observe it like this, it's also not correct. You definitely have to place it on a flat surface, and you have to go align with the, you have to go into the level of the meniscus like this, right? So I can see it's 90 milliliters. I hope you all can see so, right? So that is the correct method of measuring a liquid in the lab. So was it clear how to measure a certain volume of liquid using the measuring cylinder? So you have to keep in mind, you have to place this measuring cylinder on a flat surface, and when you measure a certain amount of liquid, you have to take your eyes in level with the lower curved part of the meniscus. Right, children? I hope it's clear now. Okay, children. What do we have here? Characteristics of liquids. So in order to study the characteristics of liquids, we are going to do this experiment. So we all know what are the steps coming under an experiment, right? So experiment, or the title here is find out the characteristics of liquids. So what do we need? What are coming under materials? We need, what is this now? This is, you all know, this is a measuring cylinder, right? We need a measuring cylinder. What can you see here, children? different containers. We have different containers with different shapes. So we need some of these containers. When you do this at home, you might not have the same type of containers, but you can find other containers that you can easily find at home. Okay? So I will show you. This is a test tube, right? This is a tube shape. This is known as the test tube. And this is a flask, and this is known as a conical flask. And this is a round bottom flask. Okay, so when you do this at home, you can find whatever is available. Understand? So however, we need containers of different shapes. Containers of different shapes. Right? So what do we need to do? We are going to see now. Right. So what do we have to do under the method, children? Listen carefully. You have to measure the equal amounts of water. It's good if we can use colored water, so it's very easy to see that. Okay? It's very easy to observe that. Therefore, I am going to measure 200 milliliters of colored water using the measuring cylinder, and each time I am going to measure 200 milliliters of colored water, and I am going to transfer that water into each of these containers with different shapes. Understand? I am going to use here 200 milliliters. If you read the textbook, it has given 25 milliliters. I am using 200 milliliters. So when the amount is more, we can observe very clearly. Understand? So under the method, we are going to write, we have to measure 200 milliliters of colored water and put them into the different shaped containers. Right. Measure 200 milliliters of colored water and put into the containers of different shapes. Understand, children? So, we need the measuring cylinder and containers of different shapes. We have to measure 200 milliliters of colored water each time, and we have to transfer them into the containers with different shapes. And we have to observe what happens to the shape and the amount or the volume of these liquids. Okay? Right. So we wrote the method here. Now we are going to see the experiment. Now we are going to see the characteristics of liquids. So you all can see I have here different types of vessels, right? Different shapes, different sizes. And here I have 3 beakers with water with different colors. So first of all, I am going to take this green colored water and I am going to transfer it to this flask. This is called the flat bottom flask. See what happens. What happened to the shape of this water? Earlier, when this amount of colored water was in this beaker, it took the shape of the beaker. But when I transfer this water into this flat bottom flask, it takes the shape of this vessel, this flask. Okay? I'm going to take this one and I'm going to transfer it to this flask. This is called the conical flask. Now what can you tell about the shape of these children? Earlier it took the shape of the beaker, but now it takes the shape of this flask, right? Conical shape. And this green color water takes the shape of this vessel. So what you all can see according to this one, there's no definite shape for this water or the liquid, right? Liquid, when we change from one vessel to the other vessel, the shape also changes. Now we are going to check whether what happens to the amount or the volume of a liquid when we transfer it from one type of vessel to the other type of vessel. So here we have colored, red colored water, 200 milliliters of water I have. I am going to transfer it to this measuring cylinder. Now you all know that how to measure it correctly. I am going to first transfer it. And in order to check whether what is the volume of the certain liquid, you all know that you have to make your eyes level with the meniscus. We explained it before, right? So it is exactly 200 milliliters. So what happens, even though the shape of the liquid changes from one type of vessel to the other type of vessel, but the volume of the liquid will still be the same. It means we can come into a conclusion that shape of a liquid is not fixed, right? But when it comes to the volume of a liquid, liquids have a fixed volume. Okay, children. So after doing this experiment, I hope you remember what you saw in this. Okay. So when I put 200 milliliters of water, colored water, into different vessels, different containers with different shapes, what happened, children? It took the shape of the container. Okay. The shape of the amount of water also changed according to the shape of the container. Understand, children? What happened to the volume of the liquid? What happened to the volume of the water, children? Did the volume change? Do you remember I measured 200 milliliters of water, red colored water, and I transferred it to the measuring cylinder. What was the volume, children? It was still 200 milliliters. So, what did you observe? You observed that volume was a fixed one. Whatever the container you take, volume will be the same. But what can you tell about the shape, children? Was the shape the same? No, it was not. Shape of the liquid was the shape of the container. So we will write those two observations. Right. Number 1. Shape of the water changed according to the shape of the container. Right? Number 2. Volume of the liquid. Liquid. Oh, here we used water. Did not change. Okay. Shape of the water changed according to the shape of the container. Okay, but volume of the liquid or water did not change according to the shape of the container. Understand, children? So, what can we decide after doing this experiment, children? I'm sure you know this now. Okay, we can decide when we take a liquid, it doesn't have a definite shape. It always takes the shape of the container. What can we tell about the volume of a liquid, children? Does the volume also change from one container to the other container? No, it is not. Volume doesn't change. Therefore, volume is a fixed value. Understand? We will write. Conclusion. Liquids do not have a definite shape. It takes the shape of the what? Container. It takes the shape of the container. Right, children? At the same time, liquids have a definite volume. Volume doesn't change time to time. Okay, so I'm going to take this. Liquids do not have a definite shape, no fixed shape. Liquids have a definite volume. Understand, children? So according to this, what are the characteristics of a liquid? A definite volume present, no definite shape. A liquid has a definite volume and a liquid has no definite shape. Do you understand this, children? I hope so. We'll see some other examples. Matter in liquid state. Already you know there are so many examples for liquid state, right? Here we have water, milk, coconut oil. What else? We have kerosene oil. Okay, these type of things are coming under liquid state. Okay, children. So you also can look at your environment and find what are the matter present under liquid state. Okay, children. Now we are going to see the characteristics of gases.